In this chapter, we will talk about milligrams and milliequivalents and the usefulness of milliequivalents and how to convert milligrams to milliequivalents and vice versa in solutions of electrolytes. So the objectives of this part will include to understand that electrolytes play several important roles in the operation of the body, and to understand that milliequivalents are used as units of measurements for electrolytes in the body, and what milliequivalent represents. And also to learn how to convert milliequivalents to milligrams per unit volume, and how to convert milligram percent to milliequivalents per liter and vice versa. We have learned from the previous chapter that electrolytes carry an electric charge when dissociated. So we have anions that carry a negative charge, such as chloride and sulfate ions. And also we have cations which carry a positive charge, such as sodium, potassium, and calcium. Normally, blood plasma contains 154 milliequivalents of cations and an equal number of anions. This equal number of anions and cations in the milliequivalent units helps to maintain acid-base balance, and helps to maintain water volumes and to regulate body metabolism. So this is the function of these electrolytes. Therefore, when large volumes of fluids or electrolytes or both of these are lost, the body requires electrolyte replacement and also fluid replacement to re-establish this balance. Now we will talk about milliequivalents in more details, their definitions, their uses, and the conversions to other units. A milliequivalent is a measurement of the chemical activity of any electrolyte, taking into account the valency and the total number of ionic charges. To describe the chemical activity in a closer way, we can say that it represents the fact that any number of milliequivalents of any cation will always react with the same number of milliequivalents of any anion. But remember, in milligrams, they will weigh different amounts. That's why it's easier and more convenient to use milliequivalents rather than milligrams to account for electrolytes inside the body. So remember that a milliequivalent is not the weight of an anion or cation, but it is the number of ionic charges or chemical activity of that anion or cation. We can convert milligrams to milliequivalents and vice versa. For example, to convert milligrams to milliequivalents, we can use the first formula shown in this slide, where milligrams can be multiplied by the valency of the ion, and the product will be divided by the molecular weight to get the value in milliequivalents. And if we want to convert milliequivalents to milligrams, we can use the second formula shown at the bottom of this slide, where milliequivalents can be multiplied by the molecular weight, and the product will be divided by the valency of the ion to get the value in milligrams. Remember that we can use these same formulas to get the units per unit volume. So we can use milligram per liter or milliequivalents per liter by just incorporating these into the previous formulas, as we will see in the examples next. This slide is just a reminder of what we have already studied in the first chapter of solutions of non-electrolytes. You remember that the equivalent weight or the gram equivalent weight is the molecular weight divided by the number of equivalents or the valency. Therefore, milliequivalents is the weight in milligrams divided by this gram equivalent weight. So milliequivalents will be milligrams divided by the gram equivalent weight. You can see these formulas in this slide, and note also that if the valency was equal to 1 as in monovalent entities, milli equivalent in this case will equal the weight in milligrams divided by the molecular weight, and using this definition the milli equivalent will be equal to millimoles. This slide shows an example on how to convert milli equivalents into milligrams. In this example, it is required to know the concentration in milligrams per ml of a solution containing 2 milli equivalents of potassium chloride KCl per ml. 2 milli equivalents per ml. To solve this problem, we should first know the molecular weight of the salt, potassium chloride. It is mentioned that the molecular weight is 74.5 grams per mole. Therefore, we can use the second formula in the previous slide, where milligrams can be obtained by multiplying the milliequivalents by the molecular weight and then divide by the valency of the ion to get the values in milligrams. So we input all the values. Specifically, we multiply 2 milliequivalents per ml by the molecular weight, which is 74.5, and we divide by the valency for either potassium or chloride, which is 1, and the result is 149 milligram per ml. This is another example on how to convert milli equivalents into milligrams. In this example, it is required to know the concentration in grams per ml of a solution containing 4 milliequivalents of calcium chloride, which is calcium chloride CaCl2 2H2O per ml, 4 milliequivalents per ml. To solve this problem, we should first know the molecular weight of calcium chloride. It is not given in this question, but we can simply calculate the molecular weight. Since it is an additive property, we just add the atomic weights of calcium chloride, and also we add the molecular weight of 2H2O. So the molecular weight is calculated to be 147 grams per mole. Therefore, we can use the second formula in the slide 4, where milligrams can be obtained by multiplying the milliequivalents by the molecular weight and divide by the valency of the ion to get the values in milligrams. So we input all the values. Specifically, we multiply 4 milliequivalents per ml by the molecular weight, which is 147, and then divide by the valency, which is 2. It is for calcium or for 2 chlorides. That's why it is 2. The result of this multiplication and division will be 294 milligrams per ml. And since it is required to convert this into grams per ml, then we divide by 1000. So the result will be 0.294 grams per ml. This is another example to convert into certain percentage concentration, which is weight per volume. from milliequivalents. So basically it is a conversion from milliequivalents to percent weight per volume. What we do is, first we should know the molecular weight of this salt, which is ammonium chloride, and then we calculate the milligrams, and then we convert this milligrams into percent weight per volume, and I suggest that you go over this example, and it is all set for you, and the result is also given. This slide shows an example on how to convert milligrams into milliequivalents. In this example, it is required to express this concentration, which is 10 milligram percent of potassium ions, in terms of milliequivalents per liter. To solve this problem, we should first know the atomic weight of potassium ion. The atomic weight of potassium ion is given to be 39 grams per mole. Therefore, we can use the first formula in slide number 4, where milliequivalents can be obtained by multiplying, the milliequivalents can be obtained by multiplying the milligrams by the valency and then dividing by the molecular weight or the atomic weight. So we input all the values. Maybe first we can convert the milligram percent into milligrams per liter to get the value of milliequivalents per liter. Specifically, 10 milligram percent equals 10 milligrams per 100 ml. Therefore, for 1000 ml of which is 1 liter, we should have 100 milligrams. So simply 10 milligrams percent equals 10 milligrams per 100 ml. So for 1000 ml, we should have 100 milligrams. So the new concentration is 100 milligram per liter instead of 10 milligram percent. Now we work on this number, which is 100 milligram per liter, and we include it into formula number 1, and then we multiply this by the valency and divide by the atomic weight, and therefore the result will be in the milliequivalents per liter, and in this example it is 2.56 milliequivalents per liter. This slide also shows an example on how to convert milligrams into milliequivalents. In this example, it is required to express the concentration 10 milligram percent of calcium in terms of milliequivalents per liter. So it is very much similar to the previous example, except for changing the ion type from potassium into calcium ions. So first we should know the atomic weight of calcium, which is 40 grams per mole. Therefore we can use the first formula in slide 4, and also we convert the 10 milligram percent into milligrams per liter as we did in the previous example, and we just input all the values in the first formula, and the result will be 5 milliequivalents per liter. This slide contains several practice problems so that you can practice on conversion of milligrams to milliequivalents and vice versa, and to be familiar with such conversions. Please try to solve these by yourself or in groups.